Boom, there we go. All righty. So y'all, let's take a look. Let's see if we remember how to do some of this stuff. Because y'all, like this question here came out at 2.1. So this is something that we did back in January when it was still real nice and chilly outside and all that kind of good stuff. Remember those days? Man, I don't know about you guys, but I wish it was cold again. All righty. So y'all, let's see if we can figure out how to do some of these questions. So it says, look, let's use the frequency distribution shown to construct the expanded frequency distribution. Okay, so we have, let's see, 1, 2, 3, 4, 5, 6, 7 classes, right? And so y'all remember, these are the class ranges, right? And the frequency tells us, um, we're looking here, y'all, we're talking about temperatures, right? So we're looking at temperatures between 18 and 28 degrees, 29 and 30 degrees, or 39 degrees, I'm sorry, 40 to 50, so on and so forth. And these are the number of days that had temperatures in those ranges, right? So let's see. First question, does anybody remember how do we find the midpoint of a class? Anyone remember? There we go. Awesome. Very good, y'all. We're going to take 18 and 28. We're going to add those folks together. 18 plus 28. We're going to add them together. And then we're going to what? Divide by 2? So 23, right? So y'all right here, we're going to put it 23, right? And then y'all, we could do the same thing for the next one, right? We could say, look, what's 29 plus 39? Boom. Let's divide that by 2. We get 34. Okay, now we could keep playing this game over and over and over again. But y'all, remember we talked about something called the class width? And the class width told me how much do I need to add from 18 to get to 29? Anybody know? What's the difference between 29 and 18? 11, right? Very good. 11, right? And then look, y'all, if you add another 11, you get here. Well, we can play that same game coming down this way, right? So look, if this one is 23 and the next one is 34, what do you think the next one's going to be, y'all? If we keep adding 11, what, 43? If we add 11 again, wouldn't that be 54? If we add 11 again, wouldn't that be 65? Another 11 would be 76. Anybody know on the last one? 45. You're right. My bad. Oops. Oops. 45. And then this becomes what? 56. Let me fix that. I'm so sorry, y'all. 56, 67. Isn't this going to be what? 78? And then, okay, what about the last one now? 89. Boom. There we go. Awesome. Very good. That was my bad. Let me fix that. Oops. Okay, now let's see if we can find the relative frequency. Y'all, in order for us to find the relative frequency, we need to find the total number of entries, meaning we need to add up all the numbers in our frequency. Can somebody do me a favor? Will somebody do me a favor and add up 18 and 41 and 66 and 67? 365. Awesome. Very good. 365. Okay, now let's figure out the relative frequency. Y'all, the way we're going to find the relative frequency is we're going to take each of these numbers here and we're going to divide them by 365. So look, the first one is 23. We're going to divide that by 365. Y'all, I want you to notice something here. It says we're going to round to the nearest hundredth. The nearest hundredth, my friends, means we're going to put 2 decimal points. So point and then 2 digits to the right of that. What do you guys think? 0.06? Oops, sorry. Still got my highlighter on. 0.06. Okay, and then let's try the next one. 34 divided by 365. 0.09. Okay. And then we're going to just keep playing this game, y'all. 365. 0.12. 56 divided by 365. 0.15. Okay. I'm sorry. You know what? I'm putting the wrong numbers, y'all. Sorry. Sorry, y'all. I need to take these numbers. My bad, y'all. Sorry.
You divide that by 365.
Yeah, I'm dividing those numbers by 365, not my midpoints. Sorry, guy. I don't know why I did that. I'm sorry. 18 divided by 365. 0.05. My bad, y'all. Okay, 41 divided by 365. 0.11. Let's see, 66 divided by 365. 0.18. 67 divided by 365. 0.18 again. 81 divided by 365. 0.22. And didn't we already do 66 before? And we got 0.18? And now we have 26, right? 26 divided by 365 and 0.07. Here we go. Okay, much better. All righty. So now when we're going to find our cumulative frequency, y'all, when we're going to find our cumulative frequency, what we're going to do is we're going to take that number 18, and that's the first one we have, okay? Now, cumulative means like it's accumulating, it's building up. So for the next one, we're going to add 18 and 41. So let's see, what's 18 plus 41? 59, right? So that's going to be the number I'm going to go there. And then I'm going to take 59 and I'm going to add what, 66 to it now? Because that is the next one. I'm going to try to make my calculator a little bit smaller so we can have everything here on the same size. Okay. So we did 18 was the first one, right? And then how do we get 59? We did 18 and what? 41. And now we have that 59. We're going to add what to it? 66, right? And that's giving me what, 125? And then from 125, we're going to add what, 67? And that's going to give us 192. Okay. And then from 192, we're going to add what, 81? And that's going to give us 273. And then from that, we're going to add what, 66? And that's going to give us 339. And then if we add that other 26, shouldn't we get 365? Because that's how many days we had in total. And there we go. All right. So again, y'all, we can see that as we're going through this thing here, the way, again, we find the midpoint is we take the upper and lower limits of our classes, add them together, divide by 2, and you can keep playing that game all the way down. Or if you know the class width, like to get from the lower class to the next lower class, we were adding 11, then we can continue to add 11 down here, right? And then how do we find our relative frequency? We take 18 divided by 365, 41 over 365, right? 66. Each of those frequencies divided by the total. How do we get the cumulative? The first one is still the same thing, 18, but then start adding each of the next ones all the way down. Okay. All right, let's take a look at number 2, y'all. Number 2 says, for the dot plot below, what is the maximum and the minimum entry? What's the lowest number we had, y'all? 12. And what was the biggest one we had? 17, right? So doesn't that look like that's going to be choice, what, D? There we go, right? We're just looking at our dot plot, right? It's just an arrangement of numbers. Right? And y'all, just as a reminder, remember what the little dots mean? That's how many 17s we had, right? So we had like 2 17s, 2 16s. There was only 1 15, right? But we had what, 1, 2, 3. We had 4 14s. That's what the dot plot really means, right?
Why wouldn't it be 14?
Because what is the biggest? So it's not asking you which one had. It's not asking you which was the greatest frequency. It's asking you what's like the lowest number and the highest number. Right. Right. In terms of our range, right? So remember how we find the range? We take the highest and the lowest and we subtract. That's really what they're asking you there. Okay. So y'all, just to give you a heads up, when I'm getting to question number 3, it says, look, A mean score of a placement exam for an entrance into a math class is 80 with a standard deviation of 10. Use the empirical rule to find the percentage of scores between 60 and 80. Okay, so y'all, they're asking me to use the empirical rule. What I'm going to do here, my friends, I'm coming back to my my week 15 document. Y'all, I'm going to click on my formula sheet for test one. If you still have it, y'all, you can use it. If you don't, y'all, I didn't bring any copies because honestly, the copy machine, y'all, in where my office is it's on the fritz right now. But just to give you a heads up, if you click on these things, again, they're PDFs. You can open them up. You can save them. If you go next door to the CLE, you can print them out there. Okay. But y'all, this is what I want to use. I want to use this bell-shaped distribution. So let me show you what I'm going to do here. Let's go like this. Let's copy this guy. Let's come back this way. And I'm going to put it over here. We're going to drop it like it's hot. There we go. Okay, so let's take a look, y'all. We know that our average is 80, right? So my X bar is 80, and my standard deviation is 10. Okay, so look, let's do it like this, y'all. Let's come back here. This is 80. The difference between each of those values, y'all, is going to be 10. Okay, all the way down. So if this is 80, do you guys agree that's 90? That's 100. That's 110. Wouldn't this one be 70? And wouldn't that one be 60? And wouldn't that one be 50, right? Okay, now let's think about what the question's asking us. They're asking us for just the percentage of scores that lie between 60 and 80. So look, y'all, between 60 and 80, we are looking for that percentage right there. So what percentage are we looking for? 34 and 13 and a half. And if we were to add those two percentages together, wouldn't that be 47.5%? Because that's really what we're looking at. So then y'all look, I'm going to come back over here, sorry. And we're going to say, hey, look, doesn't that look like our choice B? Boom. And there's my answer. But y'all, one thing I wanted to mention here. In doing this problem, what told me to use that little chart was that phrase right there. Can we use the empirical rule, right? So notice, y'all, I came back over here. This is that empirical rule because of that bell-shaped distribution, right? I think it said it somewhere right here. Here we go. Assume that the data has a bell-shaped distribution. Okay. So look, let's do number 4. Let's do it the same way, y'all. Look, it says the mean value of land and buildings from an acre of sample farms is $1,200. So y'all, in this case, my X bar is 1,200 and my standard deviation is 2. Okay. And then it says, assume that the number of farms in the sample is 80. So my N is 80. So look, y'all, I'm going to do just the same thing we did before. I'm going to scroll down a little bit and I'm going to drop that same graph. Here we go. Okay, let's take a look. I believe they said this was 1,200. And wasn't our standard deviation something like 200? I think that's what it said according to the question. Let me just scroll back down. Yes, 200. Okay, so look, y'all, let's do this. If that number is 1,200, what number would this one be? If we add 200 to it, wouldn't that be 14, 16, 1,800? And then wouldn't that one be 1,000 and 800 and 600? Very good. Okay, so now we have that info, y'all. Let's take a look at what the question is asking me to do. I'm just going to scroll back up here. Sorry. Okay, so it says, use the empirical rule to estimate the number of farms whose values per acre were between 800 and 1,600. So look, y'all, we want to go 800 to 1,600. So bless you. So we're looking at this piece right here. Okay. So look, y'all, look at what we highlighted. Didn't that say what we highlighted isn't that 95%, right? So 95% of, how many farms did we have in our question? Anyone remember? Scroll back just so we can take a look. Sorry. We come back here. We had a total of how many farms? 80, right? So look, y'all, I'm going to scroll back this way, and we're going to say we want to find 95% of 80. So how do we find 95% of 80? We're just going to take 0.95 times 80, okay? And I'm coming up with 76. So look, let's do this. We're going to put 76 right there, okay? All right, now there is a part B. Part B says, if 23 additional farms were sampled, how many of these farms would have land and building values between, again, 800 and 1600 per acre? That's still 95%, y'all. So now we're just finding 95% of 23, right? So I'm going to do the same thing we did before. I'm going to clear this out. We're going to go 0.95 times what? 23. And I'm coming up with 21.85. Now look what it says, y'all. Round to the nearest whole number is needed. What would you say, 21 or 22? 22, right? Boom, 22, and there we go. Good, very good.
So can you go back to the real?
Yes, the picture?
Yeah.
Yeah, let me scroll back this way. Here we go. So remember, we were looking between what, 800 and 1600? So between 800 and 1600, it's this piece right here. And that happens to be what, 95%? Yeah. So y'all, again, one thing I want to mention, like this little piece right here, y'all, is helping me so much in figuring out that question, right? And again, where did I get that from? Just as a heads up, y'all, I came back here and I clicked on my formula sheet for test 1. So again, y'all, when you're going to do your exam, make sure that you either run down to the CLE, again, it's right next door, and print out those formula sheets. If our copier, y'all, is up and running again by Thursday, I'll bring some, right? But if not, just go down to the CLE, or you can just, open up a tab and, you'll have it right there, right?
Or you can probably print several ones so you can use them if there's multiple questions.
Yeah. Yeah. So like I said, our copier is kind of on the fritz right now. That's the only reason I didn't bring any, But yeah, definitely, guys, use the formula sheet, okay? And if you want to print it out, like if it helps you, y'all, so again, everybody's different, right? So some people will like print out the entire thing and they'll do everything by hand, and then they just go back and they enter in their answers. That's fine. If you're the type of person who, it helps you to have all those papers in front of you, guys, do that, right? If you're okay just going back and forth, looking at the different tabs, do that. We're in week 15. At this point, you should have found what works best for you, right? I'm guessing that's why you guys are already here, because at this point, you know what works, right? All righty. So let's take a look, y'all. I'm going to scroll down to my next question here. All righty. So, y'all, for this question here, and it says, find the 5-number summary and draw a box plot of the data. Y'all, there's a couple of ways we can do this. I'm actually going to use my calculator because I think it's going to be a lot easier if I just get my calculator going here, y'all. Let me turn this thing on. Let me clear everything out. So you look, y'all, what I'm going to do is I'm going to take my calculator and I'm going to enter all these numbers in a list. So if you remember how we did this, I think we said we're going to go to stat. We're going to go to edit. Okay, so y'all, on my calculator, everything is already cleared, right? If yours was not, you could use a little up arrow, hit your list 1, hit the button that says clear, and everything should be good. Okay, so look, I'm going to go down my list. Oh no, what did I do? Okay, let's try that. Is it enter? Oh, still not enter. Maybe it's 3. Why is this not working? Stat, edit, list. Let's try here, 3. There we go. Okay, 8. Looks like we got 8 again. We got a 5. We got a 2. We got a 9. We got an 8. That looks like a 6. And then a 9. And a 5 again. And a 9 again. And a 4. And a 1. And a 5. And a 2. And a 9. And an 8. And a 6. And a 7. And a 9. There we go. Boom, we got it. Okay, so it looks like we got 20 numbers here, y'all. Okay, so now this is what I'm going to do. I'm going to come back to stat. I'm going to go to calculate, right? And we're going to do our one variable stats, okay? And y'all, on my calculator, again, this is, I know mine says a TI 84 plus. This is actually a TI 83. That's the software that I have for this thing. So you want to make sure that you have your list 1 there, right? So I'm going to do that. And frequency, you should probably have list 2, but there was not, make sure that your list 2, guys, is clear, okay? So if you have a bunch of numbers in your list 2, make sure that that's cleared out, okay? Let's hit enter, here we go. Okay, so look, y'all, I'm gonna scroll down my list. And look what it's telling me. My minimum is 1, okay? So let's enter that guy in, okay? And my Q1 is 4.5. Okay. And my median, which is the same thing as my Q2, is 6.5. And I believe this one was, oops, not 8.8, but 8.5. I come back to my thing here, and my maximum should be 9. Okay. Scroll down, hit your little down arrow. Okay, so now, y'all, I'm going to come back over here. And I'm going to try to say, okay, look, let's see where's our min, what's our max, all that kind of stuff, according to a dot plot. So remember, y'all, the minimum is going to be, from your perspective, the number all the way to the left. So which one of those starts off at a 1? If I look at my pictures up here, y'all, if I look at my A, B, C, and D, which one looks like it starts off at a 1? B, right? So far, B is looking pretty good. Okay, so I'm looking at B. Here's my Q, here's my minimum, right? Boom, right there. Okay, my Q1, y'all, should be 4.5. That's going to be, boom, that number right there. That looks roughly like 4.5, right? My Q2 should be 6.5. Boom, that number right there. My Q3 should be 8.5. Boom, right there. And there we go. So I'm looking at B's looking pretty good to me, right? B's looking pretty good to me.
That's cool, sir.
Right? Pretty neat on how to do it. And there's your answer, right? And you got it all set up.
It's better than doing it by hand.
Better than doing it by hand, right? Okay, so y'all, to me, the hardest part in doing this question here is when I put those numbers in, not screwing up putting those numbers in my calculator. That's really the hardest part, right? So y'all, if you notice when I did it, right, when I was entering my numbers, I said, and I'm talking to myself, not just because you guys are here, but even if when I'm in my office, right, I'm going through this stuff, I'm telling myself, okay, I got a 3, I got an 8, I got another 8. I'm talking to myself through it because for me, like hearing myself saying it and entering those numbers in just makes so much sense, right? Y'all, the one thing I want to mention is, again, I'm going to scroll back over here real quick, y'all. How much time do you have for your test? 5 hours, right? You got 5 hours. Guys, there's only 17 questions. It's not going to take you 5 hours, but I'm trying to give you that time so that you don't feel that pressure of the time, right, taking the test. So like if I were to say, guess what? We're going to take the test in class next Thursday. Now you know you got an hour and 45 minutes, right? And when you're doing that, you're going quick, right? And your stomach's all making all these noises, right? Because you're nervous or anything. I'm trying to take that element out of the testing part. So again, take your time. Take your time with it, because I'd hate for you to get the question wrong because you went too fast. Okay. All righty. Let's take a look here, y'all. It says the ages of winners of a cycling tournament are approximately bell-shaped. The mean age is 27.5 years with a standard deviation of 3.7. The winner in one recent year was 26 years old. Can we transform this age to a z-score? Okay, so look, y'all, I'm going to come back to my formula sheet. Boom, right here. There should be a formula Here we go for my z-score. Okay, so look, y'all, I'm going to copy that down. I'm just going to write it on my page here. So z equals x minus mu over sigma. Okay, so let's take a look, y'all. See what we got. Remember, this mean age right here, y'all, that's my mu. Okay. Standard deviation, that's my 3.7. Okay. That 26, that's my x. So look, this is what we're going to do. We're going to go 26 minus 27 and a half divided by 3.7. Okay. So look, I'm going to go 26 minus 27.5. Hit equals, divided by 3.7. Hit equals. Okay, now they're asking me to go to 2 decimal places. What do you guys think? Negative 0.40 or 0.41? What do you guys think? Yeah, let's go 0.41, right? So negative 0.41. Okay. Okay, so now it says at age 26, the standard deviation is, so see how we came up with a negative number, y'all? Okay, forget about the negative right now. Just think about the absolute value. Remember when we talked like years ago, right? We didn't really talk about it in our class a whole lot because you're kind of supposed to know what absolute value is. Y'all, when I think of positive numbers and negative numbers, the easiest way to think about it, positive numbers, how much money you have. Negative numbers, how much money you owe. So right now, if I were to think about this in terms of money, would you guys say that's like 41 cents? Okay, so let's go like this. It is 0.41 standard deviations. Because it's negative, is it above or below? Below. Right? Why below? Because it's a negative number, right? So if I were to say, look, negative 0.41, that means you owe me 41 cents. How much money do you owe me? 41. And do you have it or do you owe it? You owe it, right? Why? Because it's negative. Yes, ma'am.
So on that question, that would be positive.
So you would say above.
So above, and then the number would just stay the same.
The number stays the same. Yeah.
But if it's a negative, you would.
It's still, yeah. So if it's a negative number, I'm only looking at the absolute value of that number. So if it's a negative number or positive number, you're going to put the positive number in, whether it's positive or negative. The only thing you're going to do different is if it's positive, you're going to say it's above. And if it's negative, you're going to say it's below. Does that make sense? So I'm so glad you asked that question, y'all. So when she's doing hers right now, as we're going through it, and hers came up to a positive. So y'all, I want to mention, remember, when you guys are taking your test, right, there's 17 questions that come directly out of here. Y'all, what they do is the numbers change, right? So again, if this question is on my exam, it's possible that that number could be positive. It's possible that that number can be negative. It's just going to depend, right? But that's the only part you got to figure it out. Okay, so now we want to know, is this thing unusual? Look, y'all, I'm going to come back to look where the unusual scores, y'all. The unusual scores are numbers between -2 and -3 or 2 and 3. Usual scores are between -2 and +2, right? And we came up with what, like a 0.41? So let's see. No, it's not unusual. Okay. It's not unusual because a score between -2 and +2 is not unusual, right? And you say, what do you mean by that? Look, it's not unusual to get a score somewhere in that range. Okay. So yes, I want to show you something else. When I printed this thing out, so I'm glad, Natalie, you asked that. When I printed this thing out, see right here, it has a number 1. They're asking you, is it going to be above or below? Right. And in my case, it was below because it was negative. In your case, because you got a positive number, it was above.
Sure. There's not a way, like, you know how you do the Z-test, you just plug it in and the calculator and you get it? No.
Not really, but I mean, look at the formula. What did I do? Take 2 numbers, subtract, and then divide. Guys, the one thing I want to mention, if you notice when I did this subtraction, y'all, and I didn't use my TI, right? I just used my basic calculator. But even if you're using your TI, actually, let me do it this way. If you're going to use your TI, y'all, let me clear this thing out. When you're going to enter something like this in, I recommend, and I know I should have written it down, and I didn't. That was my bad. but do it in parentheses. The reason being is that if you don't do parentheses and you enter everything like this, the parentheses tells me it's going to do the subtraction first. Okay, if I don't do the parentheses, it's going to take 27 divided by 3.7, and then it's going to subtract that number from 26. Okay, so that's how I'm getting that answer there. Okay, so I'll tell you what, let's do this. Boom. Just so that we don't forget. All righty. Let's go to number 7, y'all. It says a restaurant offers a $12 dinner special that gives us 6 choices for an appetizer, 11 choices for an entree, and 3 choices for a dessert. How many different meals are possible when you select an appetizer, an entree, and a dessert? Y'all, is there a number in this question that I'm not going to use? Very good. We don't need to use the 12, right? That's not the important part. Look, y'all, we're going to pick an app. We're going to pick an entree. We're going to pick a dessert. How many appetizers can we pick from? 6, right? How many choices for entrees? 11. And how many for dessert? 3. And that's all we're going to do, my friends. 6 times 11 times 3. 198 different options. Right? Y'all, I'm sorry? That was so simple, right? When we did it, did it seem harder? When we went through it back in the day? More challenging? Yeah, I know what you mean. Guys, I know we said we didn't have to use the number 12, but I don't know about you, but like Chili's has 2 for $20 or whatever, $12 sounds like a whole lot of a better deal, right? For an appetizer, an entree, and a dessert. It's like, man, yeah, who's running this restaurant? Used to be 3 for $10.
Oh, you have to choose which color you want.
Yeah, right. All righty. So look, y'all, let's keep working down here. We're doing pretty good, y'all. Let's take a look. It says use the frequency distribution to the right, okay, which shows the number of voters in millions according to age. Find the probability that a voter chosen is in the given age range. And it says not between 18 and 20 years old. Okay, let's do this. Y'all, when we did that very first question this afternoon, remember how we found the sum of the frequencies? Let's add up those folks right there. And again, y'all, I got a 6.5, right? I do this, y'all, because this helps me. 23.9, right? 27.8, 58.7, and what is that? 29.9. Okay, so my sum here, y'all, is 156.7. Okay, I needed to know that, y'all, because we need to figure out. Remember, if we're going to use a probability, the probability is always going to be part out of the whole. So this here, that's our whole, right? That's the number of people who voted. Okay. Now, y'all, there's a couple of ways we can do this thing. It says not between 18 to 20 years old, right? So we want all of these folks here. We want all of those except for the 18 to 20-year-olds. So one thing we can do is we can find the sum of those numbers. And the easy way to find the sum of those numbers, y'all, is remember, we know all of them is 156.7. So all we need to do is take away, what, the 6.5, right? And then we can take that number and divide it by 156.7. And let's get this. And they want us to round to what? 3 decimal places. My friends, would you say 0.958 or 95.9? 95.9, right? So 0.959, and there we go. Now, y'all, just to give you a heads up, another way we could have done this, we could have said, look, let's take 6.5 and let's divide it by the total, 156.7, and we get that number there. And then remember, if we're trying to find the everybody except that guy, we can take 1 minus, I already forgot what I had, 0.04, I don't know, 1, I guess, because there's my 0.959, right? So whichever way is easier for you to do it.
What was that again, sir? Sorry.
So I took the 6.5 divided by 156.7, and I came up with 0.041. And then remember, we're trying to find everybody except that guy. So let's do 1 minus that answer. And that's how we got the 0.959. All right. So y'all, do y'all remember the microwave problem? This was the one that was like, man, what's going on here? Okay. So y'all, let's see if we can figure out the microwave question. Okay, it says a shipment of 7 microwaves contains 2 defective units, and the restaurant is going to buy 3 of them. What's the probability that we get at least 2 non-defective units? Okay, so let's think about it like this, y'all. We have 7 microwaves, right? Okay, out of those 7, 2 of them are defective, right? Doesn't that mean if 2 of them are defective, doesn't that mean 5 of them are not defective, right? Okay, so y'all, how many are we going to buy? Anybody know how many we're buying of these things? What does it say? Anybody see how many we're buying? 3. Boom, here we go. Look, y'all, I think it's always easier to do our denominator. Out of the 7, we're going to pick 3, okay? Now, we want to make sure that at least 2 of them are not defective, okay? So let's think about it this way, y'all. If we're going to get 2 that are not defective, at least 2, that means 2 or more. So out of the 5 that are not defective, we could choose 2 of them, which means out of the 2 that are defective, we're going to choose 1. Or we could pick all 3 from the non-defective, and out of the 2 that are defective, we're not picking any. Now, y'all, when you do this on your calculator, this is going to be how I recommend that you enter your numbers in, okay? So, y'all, let's see if we can figure out, like, man, where are all those numbers going to go in, okay? So look, y'all, I'm going to get my calculator. Let me turn it on. Sorry. Let me clear everything out. Okay, first thing I'm going to do, I'm going to open up that first parenthesis. Boom, there it is. Then I'm going to open up parenthesis again, and I'm going to hit 5. Now, on my calculator, y'all, I'm going to go to math. I'm going to go to probability, and I'm going to go down to number 3, and we're picking 2 of them. Now, y'all, remember, if you're using one of the calculator apps, sometimes you have to do the math and then go to number 3, and then you got to go back and enter in the 5 and the 2, okay? It's depending on what kind of calculator you got. 2, math, probability, we're going to choose one of those guys, okay? And then we're going to add, let's see, 5, math, probability, we're going to choose 3, and then parentheses again, we're going to go 2, math, probability. We're not going to choose any, okay? And I'm closing this green parenthesis here. Now I'm going to close my other one, and then we're going to go divide, parentheses, 7, math, probability, and we said we were choosing 3 because that was my denominator, and I'm going to hit enter. And y'all, I believe they're asking me to go to 3 decimal places. And y'all, I'm coming up with a 0.857. I'm sorry? You don't like that question? Okay, let me ask you a question. Does it make sense now? Or not really? Okay. So let me ask you this. Are you okay how I came up with my denominator? Okay, so remember, we have 7, we're buying 3. So Natalie, I'm glad you're asking me this because, again, if this question is on your test, I don't want you to miss it because you're like, I struggle with it. I always think it's easier to do the denominator first. That's why I set that up. Now remember, we have a total of 7 microwaves. 2 of them are defective. That means 5 are not, right? So when it says find the probability of getting at least 2 non-defective, that means out of these 5, we can get 2 of them, and then the other one, because we're going to have 3, comes from that group. Or at least 2 non-defective. That means actually all 3 of them can be non-defective. So out of these 5, we're going to pick all 3 of them from there. So out of these 2, we don't pick any. Hopefully that makes a little bit more sense. And if you want, we can try it, like after a while, like at the end of class, if you want, we can do similar questions just to make sure that we're good, right? But yeah, I agree. It's a challenging question. It's a challenging question.
Is there an easier way to do it, sir?
That's about the easiest way I can tell you, my friend. There really is. So guys, one thing I always tell my students about stats is like, guys, remember when we were doing confidence intervals and stuff like that? We go to stat, right? We can go to test. We can go to test, right? You say, oh, look, we're going to do a Z interval, right? Okay, we're going to go to stats. Let's enter this in. And we could just kind of put our numbers and we get our interval, right? Yeah. So for certain things, hey, it's really easy breezy cover roll as long as you know what you're doing, right? Are you doing a Z interval test? Are you doing a T interval test, right? What are you doing? Some of the stuff can be easy breezy cover roll. Some of the stuff requires a little bit more thought. And this is one of those that requires a little bit more thought. Y'all, what I will say is the easy part is that we're still using our calculator to do that 5 choose 2 business, because in all honesty, y'all, there is a formula on how to do this, and it requires a lot more involvement, like with factorials and all this kind of stuff. So this is like the easier way, okay?
Because that's a long way to factorial.
They're doing the long way with the factorials is the long way, and like the commercial says, right? Ain't nobody got time for that. All right, so let's take a look at number 10 here, y'all. It says, look, use the probability distribution to complete parts A through D below. Okay, so look, y'all, it's a probability distribution. It's talking about the number of TVs in a household in a small town. So if we were to think about this, okay, just so we know what this means, what this piece that I highlighted means, what's the probability that somebody does not have a TV at all? 0.01. What's the probability that a certain family has only one TV? 0.16. 2 TVs, 0.32. 3 TVs, 0.51. That's where we stopped, right? Okay, so look what it says. Part A, find the probability of selecting a household that has 1 or 2. So 1 or 2, y'all, it's going to be those numbers right there, right? So look, we're going to go 0.16 plus 0.32, and that should be something like 0.48, right? If I add them together.
Well, you have to add both.
You've got to add them, right? Because it's 1 or 2, right? Either they have 1 or they have 2. Okay. Now, when I look at part B, it says, what's the probability of selecting a household that has 2 or more? 2 or more, wouldn't that be 2 or 3? So that'd be 0.32 and 0.51, which should be something like what, 0.83? Alrighty. So look, y'all, I got one more question for you guys, or 2 more questions. What's the probability of selecting a household that has between 1 and 3 TVs inclusive? Wouldn't it be these folks right here? So couldn't we take 0.16 plus 0.32 plus 0.51, which is the same thing as 99? Or, y'all, couldn't we have said this? If we were trying to find these, remember, all of these numbers here together have to add up to a 1. So we said 1 minus that guy, 0.01, 0.99, right? Boom. And there's the other part. Okay, y'all, I got a question for you. What do you think it means at most 2 televisions? What do you think the phrase at most means?
2 or less.
2 or less. Very good. 2 or less. So y'all, what we're looking for is we're looking for these numbers here. Okay, so you have some options. You can add up all those three numbers, or you can take one and subtract that guy. And in either case, we should come up with 0.49.
So that would be our answer, sir, 0.49?
At most, 2 means 2 or less, right? So we just added up those three. All right, so look, y'all, let's go ahead and go to number 11. Number 11 says 59% of U.S. adults think that civil rights for Black Americans have improved during their lifetime. We randomly select 8 U.S. adults. Find the probability that the number who think civil rights for Black Americans have improved is exactly 1 and exactly 6. Okay, so y'all, this is one of those binomial distributions, okay? So let me write that here. Okay, so we want to know a couple of things. The probability. What's the probability that somebody says that they think that civil rights have improved? It's 59%, right? Wouldn't that be a 0.59? Okay. N is the number of adults that we surveyed. How many adults did we ask? What was the total number of people that we asked? Hey, do you think civil rights have improved? Anyone know? 8. Very good. Okay, so for part A, y'all, for part A, it says exactly 1. So my x equals 1. So y'all, we're going to use what we call our binomial PDF, okay? Now look, y'all, I'm going to come back to my formula sheet because I believe it is here. Oh, you know what? I think it's on my formula sheet for test 2. Sorry. Here we go. Here's my binomial formulas, y'all. So look, my binomial formula right here, PDF, look, it says N, P, and X, okay? So we're going to go N and P and X. So all we're going to do, y'all, for our question in part A, we're going to say N is 8, okay? Our probability is 0.59, and my X is 1. So I'm going to grab my calculator again. Okay, let me turn this guy on. Let me clear it out. We're going to go second vars. Okay, we're going to scroll down until we find, here we go. In my case, y'all, it's number 10 on mine. Binomial PDF, right? Okay, remember we have N, P, and X. So N is 8, comma, my P is 0.59, comma, and my X is 1, right? And we're going to hit enter. Okay, and y'all, they are asking me to go to 3 decimal places. So at least for my case, y'all, I'm coming up with 0.009.
Mine says trials.
Yeah, trials is your N,
And then my P would be
0.59, right? And then your next number should be what?
1.
There you go. Okay. Now take a look, y'all. Part B, we're going to do exactly the same thing. The only difference is in part B, isn't our X is equal to what? 6? So we're still going to do the same thing, right? We're still going to go binomial PDF, 8, 59, 0.59, sorry, and 6, right? So I'm just going to go second enter, and I'm going to change that 1 to a 6, and I'm going to hit enter here. And y'all, I'm coming up with 0.199. Again, if I'm going to 3 decimal places. There we go. Right. Y'all, we're going to do question number 12 right now. But the one thing I want to mention, what's different, because I know when we were doing this stuff back in the day, right? We come back here, we go second bars, right? And sometimes we'd use binomial PDF, sometimes we'd use CDF, okay? What's the difference between the two? The PDF tells you the probability of exactly a particular number, 3 or 7 or 15 or whatever it happens to be. The CDF is going to be a cumulative effect, okay? So let me show you what I mean by that, y'all. If I scroll, oh, guess what? We don't have one like that, so we're not going to sweat it. All right, I thought we had one like that, but we don't. All righty. Let's take a look here, y'all. Let's see if we can figure this guy out. We want to find the area of the shaded region on the standard normal curve. Okay, so look, y'all, let's see, remember how to do this. Anybody remember how do we find the area under a curve given our Z value? Didn't we go what?
Second bars.
Yeah, we go second bars. Let me grab this real quick. Let me clear everything out. Sorry. We're going to go second bars. Didn't we go to our normal CDF? Okay. So you look, y'all, where are we starting off at when we're going to shade? What's the value that we're starting off at? In our case, 1.93, right? 1.93. Because we're going all the way to the right. Didn't we used to say we're going to go all the way to what, 5,000? All righty. So let's go to number 2. Let's go 1.93, comma, 5,000, 1, 2, 3. Oops, I forgot my comma. Comma, there we go. 5,000, 1, 2, 3. Let's hit enter. And guys, it doesn't matter if you go 5,000, 5 million, doesn't really matter. And we're going to go to 4 decimal places. Y'all, I'm coming up with 0.2 or 0.0268. 0.0268. Okay, right. And there we go. Now, y'all, by default, again, just as a reminder, like if you notice when I printed this thing out, it gave me the whole table, right? And the reason it gave me the table, y'all, is by default, when you're going to do these things, right? Like I use the calculator, right? Different instructors use different methods. So like there's a software called StatCrunch. Some instructors use that. So they don't show you how to do it necessarily using your calculator. But again, you could use the table, but I think for the most part, we were pretty cool using the calculator stuff because the table does take quite some time, right? All right, let's take a look. Let's find the indicated area under the standard normal curve between 0 and 2.18. So y'all, again, just if I was going to draw a picture, right? Here's my picture. We're going to go between 0 and 2.18. That's the area we're looking at, right? So again, we're going to go normal CDF, 0, and 2.18, right? Let's do it again. Boom. Let's change this guy to a 0, comma, 2.18, and then let's just get rid of all the rest of that stuff. And drop a parenthesis at the end. And y'all, I'm coming up with something like 0.4854, I guess.
Yes, sir.
Boom. And there's my area. You guys hoping like for a bunch of questions like 12 and 13, right? Because those are the easy breezy cover ones. I'm sure you got at least one, y'all. I'm sure you got at least one. All right, let's keep going down. Ooh, let's see if we remember this one. Okay. Let's take a look here, y'all. It says draw a normal curve with a mean of 68, the standard deviation of 12. Okay, so look, y'all. Remember, the mean is going to be 68. That's telling me that the number in the middle has to be 68. That's right. So look, y'all, 68. Boom. Well, we know that choices A and C are looking pretty good so far, right? Because that's where my middle is, right? And you're like, why aren't you going to go with choice B? Because my middle number here is not 68, right? So we're going to do that. And then we're going to say, look, the first number to the right has to be whatever 68 plus 12 is. What's 68 plus 12? Anybody know? 80. Which one of those has that first number being 80? A, right? So boom, here we go. Choice A. Okay, so let's take a look and let's see if we can figure out how to answer 14 with the information we have. Okay, it says the normal distribution curve is centered at, what do we say our center was? 68, right? And it has 2 points of inflection. This one here is 80. That's going to be the bigger one. What is the smaller one? There you go. Because one of them is 68 plus 12, and the other one is 68, what, minus 12? And there you go. Y'all won 14 on the test too, right? Because that's kind of a neat one too, right? Not too difficult to do. Yo, look, we've done half of it, but what I will say is, you know, when we're doing the hypothesis testing, each one of those questions has like parts A through Q. You know what I mean? There's a bunch of parts of there. You guys want to do maybe another 4 questions, and then Thursday we just do 10? Are y'all cool with that? Or do y'all want to stop here? It's up to you guys. It's 3 o'clock. We still got some time. Y'all want to do another 4, and then on Thursday we just do the last 10? Does that sound like a plan? Okay, let's do another 4 Thursday. So let's work to 18, guys. And I'm going to upload this video, and I'm going to call it review for the final part 1, and then we'll do the other one Thursday, review for the final part 2. Let's go a little further, just because I think we got some time. Okay. All righty. Let's take a look, and let's see if we can figure out number 15, y'all. Number 15 says, utility bills in a city are normally distributed with a mean of 100. Okay, first thing I'm going to do here, y'all, I'm going to write down some pieces of info. My mean is 100, and our standard deviation in this case is 12. Okay, look at the first part. Part A says, let's find the probability that a randomly selected utility bill is less than 67. Okay, so look, y'all, when we're trying to figure out what's the probability that our utility bill is less than 67, what we want to do with part A, y'all, what we want to do with part A is we want to convert that number to a z-score. Okay, so look, we're going to do this. Okay, and let's see if we can't figure this out. So look, we're going to go z equals my x number in this case, my friends, 67, right? Okay, look, y'all, I'm going to write that in parentheses because, again, when I'm doing this on my calculator, that's what I got to do first, right? Okay, let's clear this guy. So we're going to go 67 minus 100, okay, and we're dividing it by 12. Okay, so negative 2.75. So look, y'all, what we're trying to figure out now, what's the probability that our z-score is smaller than negative 2.75? Y'all, I'm going to draw you a very rudimentary picture. Right here, 2.75. I am looking, my friends, for the area to the left. Aren't we just going to do this now, y'all? Aren't we just going to go second bars? We're going to go to number 2. If we're going all the way to the left, aren't we going to start at negative 5,000, comma, negative 2.75? Close that off. Let's hit enter. And we're trying to go to 4 decimal places. So y'all, I'm going to say 0.00, what, 30? Because that's the number that I'm coming up with. So we're going to go 0.0030. Okay.
So we put the negative there, sir?
Where?
Negative 0.0030?
There's no negative.
No.
No. Remember, probability always a number between 0 and 1, right? Okay, now look, y'all, let's do part B. Let's see if we can figure out part B. Part B says, what's the probability that our utility bill is going to be between 87 and $100, right? Okay, we're going to do 2 things here, y'all. We're going to convert both of those to z-scores. I'm going to call one of them Z1. Z1, I'm going to use that number 87. Okay, so let's do that real quick. let's see, let me clear this out. 87 minus 100, negative 13, divided by 12, because that was our number. Y'all, I'm coming up with a negative 1.08. Okay. The next one, Z2, we're going to go 100 minus 100 divided by 12. That should be 0. Okay. So now, what I'm going to do now, y'all, for part B is I'm going to say, what's the probability that my Z-score is between here? Again, just to give you a rudimentary picture, look, here's 0, here's negative 1.08. That's what we're trying to find, okay? So look, y'all, we're going to do the same thing. We're going to go second vars. We're going to go to our normal CDF. We're starting at negative 1.08. We are ending, my friends, at 0. And again, if I go to 4 decimal places, y'all, I'm coming up with 0.3599. Okay.
What'd you get to? 3.99?
So 0.3599.
Okay.
Okay. And y'all, I got one last part C here. Look what it says. A randomly selected bill is more than 110, right? So look, I'm going to do it like over here on the side, y'all. What's the probability that X is more than 110? All right, let me get rid of that. Okay, so again, y'all, I'm going to convert this to a Z-score. So we're going to go 110 minus 100 divided by 12. 0.83. Okay, what we're trying to figure out, what's the probability that Z is bigger than 0.83? So here is 0. Here is 0.83. I'm looking for that area, y'all. Looking for the area to the right. Okay. So look, y'all, if we're trying to find the area to the right, second vars, number 2, we're starting at 0.83. Where are we going to end up at? We're going to go all the way to, what did we say? 5,000. Boom. There we go. Let's hit enter. And again, y'all, the 4 decimal places, I'm coming up with 0.2033. 0.2033 is what I should be getting for my last one. There we go. Okay.
Now that we've been through the whole thing, I understand it.
Makes a little bit more sense.
Yeah.
A lot of times when you're going through it the second time around, it's like, that's what this is telling me. Yeah. Look, y'all, let's knock out the next couple of questions, and then we'll call it a day, and we'll do the last 10 on Thursday. Look what it says. Find the indicated score of the graph shown to the right. Y'all, so look, we have the area to the left. We're just trying to find our Z-score. Y'all remember how we do this? We're going to go second vars. We're going to go to our inverse norm, right? Remember, y'all, the inverse norm always tells me the area to the left. And it looks like in our case, we have a 0.3228, okay? So y'all, I already know that we're going to get a negative number, because if it was 0.5, the Z value would be 0. I should be coming up with a negative number. Check it out, negative 0.49 and change. They want me to go to 2 decimals, so what, negative 0.46? There you go. I bet you're saying, oh, sir, put one of those on the test too. I know. All righty. Let's see if we can do 17, y'all. 17 says the annual salary for one particular occupation is normally distributed with a mean of 124,000 and a standard deviation about 19,000. Okay, random samples are of 40 are shown. Okay, so look, we got this. Remember what that means, y'all. My N is 40. and the mean of each sample is determined. Find the mean of the standard deviation of the sampling distribution of the sample means, and then sketch the graph of the sampling distribution. Okay, so y'all, my mean should still be the same number, which was what, 124?
Yes, sir.
That was the number we have here. Okay, now, how do we find our standard deviation of our sample? The way we find the standard deviation of our sample, y'all, is we take our previous standard deviation and we divide it by the square root of n, okay? So notice, they told me here already that our standard deviation was 19,000. So we're gonna take 19,000, y'all, and we're gonna divide that by the square root of 40. So look, let me clear this out. Let's go 19,123 divided by second square root of 40. Close that off, hit enter. And y'all, I'm coming up with, I'm gonna see what they want me to round to here. Or round to the nearest integer. So 3,004. Okay. So y'all, first thing we want to figure out is if we look at these numbers here, right? If these numbers here, which ones start off with a mean of 24,000? A and B, right? Okay, then we want to see if we were to add, what was the number we got? 3,004? Which one looks like that the number right about there, or the number right about here, right where that curve kind of changes, would be about the 3,004 mark? A or B? A, right? Choice A. Boom. And there we go. Right. And you got it. All righty. So y'all, number 18 says the normal model N in 58 and 21 describes the distribution of chicken eggs in grams. Okay, it says, suppose that the weight of a selected chicken egg has a z-score of 1.78. What is the weight in grams? Okay, so look, y'all, I'm going to come back again to my formula sheet. Let me see, it should be somewhere. Here we go. Y'all, this is the formula that I'm going to use. X equals mu plus z times sigma. Okay, this formula right here, let me do it like this. Let me take this guy, and we'll come back and we will drop it over here where we got some room. Boom, there we go. That's the formula we're going to use. Okay, so y'all, didn't they give us a z-score in this problem?
Yes.
1.78, right? Okay. When they give us these numbers here, y'all, that's my mu and that's my sigma. Okay. So let's see if we can figure this thing out. X equals mu in this case, 58, plus z, which we said was 1.78, times my sigma, which was what, 21? Okay. Let's try that. Let's go 58 plus 1.78 times, we said 21.
Yes, sir.
Okay, and I'm coming up with 95.38.
Yes, sir.
Is that one of my choices?
Yes, sir.
What, choice B? There you go, boom.
Question, sir.
Tell me.
What if, like, in my example, what if they don't put the N in front of it? Does the
They
first
will.
number- They will?
Yeah,
Okay.
it'll be there. And the N stands for the normal model.
Gotcha.
And I'm sorry, so we use what function like or oh no, this is just the formula.
It's just the formula, right? There you go. So look, y'all, we went through the first 18 questions. So I'll tell you what, when we come back on Thursday, y'all, we'll start with 19 and we'll go 19 through, I believe I said there's what, 28 questions? I think that's what it is, right?
Yes, sir.
Right? Yeah, and we'll finish that up, y'all. So we'll be done. We'll do the last 10 questions on Thursday. So you notice, y'all, from the next couple of questions, it's more like stuff that we just kind of got finished doing. But some of those questions, y'all, take a little bit more time to do, right? That's why I thought maybe it was a good idea that we did 18 questions today, so we only have 10 on Thursday, okay? Let me do this real quick, y'all. Let me come back this way. Let me stop recording. Boom, here we go. Stop.